guys, Ngangaria here, back with another video. Today we're going to look at the difference between data science, data analytics, and data engineering. And these terms are very confusing and they are used interchangeably. First of all, you have to understand, if you are applying for a job or you're working for a specific client, you have to understand and learn the job description that they're giving you so that you know what you're supposed to be doing. With that said, to understand these concepts, you have to look at the data science hierarchy of needs, which was created by a lady called Monica Rogari. Monica is a data science advisor and also an author of a book called Turning Data into Products and Stories, which just explains how you can use data to as a product and to create compelling stories about data. People usually like jumping to the more sophisticated parts of data, jumping to the machine learning, creation of machine learning algorithms, and the manipulation of the algorithms, artificial intelligence, deep learning, neural networks. But you have to understand the data science hierarchy of needs for you to know what you want to do and where it lies. In the hierarchy of needs, at the base is data collection, which is the most important thing in the whole concept of data, because it's basically the gathering of the raw materials that are required in the field of data science or data engineering or data analytics. You have to understand that the data collected is what will be used, and it's the acquiring of this specific knowledge or the specific data points that will be used in the further up this hierarchy. Data collection is done by instrumentation using things like Google Forms or Device Magic or Kobu or ODK, etc., etc. You can also do data collection by using login systems of organizational login systems or Facebook. When you log into Facebook, you can find out that you realize that you are actually giving out your login details, and you're giving out information that is collected by the Facebook organization, which is a form of data collection. There's also sensors, and there's external data like collecting data from the internet, secondary sources, there is user-generated data, etc., etc. Once this data is collected, it has to be moved and stored, which is the second part of this hierarchy of needs. This data has to be moved and stored. The data movement part depends on very reliable data flow and infrastructure and pipelines. These are very helpful in moving the data from point A to point B, where they can now be stored in an unstructured or structured database. A structured data is basically the data that is in a structured form, predetermined form. For example, user ID, product type, date, etc., in rows and columns. And where unstructured data can come in a lot of forms like emails, bulk emails. It can be in any form that is unstructured, like PDFs, text messages, etc., etc. After moving this data and storing it, we move on to the third part of this hierarchy, which is the exploration of the data and the transformation. Once you get the data 90% of the time is unclean and has a lot of anomalies, and it's not prepped. This data has to be cleaned. It has to be anomalies have to be detected from this data, and it has to be prepped for the next steps. So this cleaning part usually takes a lot of time. People usually don't look at this keenly, but the cleaning part takes a lot of time. It takes a lot of time and effort, and uses a lot of methods to make sure that this data is clean. Since, as you know, there's the garbage in, garbage out. So if you put in garbage data, you'll just get garbage output, which will not be helpful for the organization. The other step is the aggregation of the data and the labeling, which involves the analytics, the metrics, the segmentation, aggregation of the data, and training the data. When I say analytics, I mean basically extracting information that is helpful to a specific organization, to help them create an impact in a certain place, providing solutions, solving problems, etc. After this, you move on to the next part, which is the learning and the optimization part. The learning part, there's the A/B testing, experimentation, and things like creating simple machine learning algorithms that help create also impact in the specific field that you are working on. After this, now there is the AI, which is the artificial intelligence, and the deep learning, which is the neural networks. And that is the hierarchy of needs, from collection to movement to exploration to aggregating and then to the learning and optimization. Now let's look at these specific professions and see what they do and where they lie in this specific hierarchy of needs. Let's talk first about data engineering. Data engineering is involved in the first portions of this data hierarchy, this data science hierarchy of needs, in the movement and storage of the data. The movement and storage of the data is basically the creation of a reliable data flow, and this is the work of a data engineer. The data engineer creates a reliable data flow and infrastructure and very good data pipelines. And also moving of this data to an unstructured or structured form. For example, let's look at an example of Booking.com or Airbnb, which offer Airbnb services, which offer bed and breakfast services to clients. There are several ways you can enter into this website. First, you can be the hosts who will host the houses. Number two, you can be a hotel because they have deals with the hotels. And number three, you can enter the website as a client, a person who's going to look for an Airbnb or a hotel. All these three ways you can enter into these websites have their own data being collected, and they are not similar to any other parts of this of the other ones. For example, a client will see the houses and can book a house or a hotel, while a hotel can only see the clients and how many clients they have, same as the host. All this data has to be stored into databases, and these databases have to also be consolidated together to form a specific database that can be used to do analytics from. And this is where the creation of data pipelines comes in. The data pipeline just basically combines all these data points using the IDs to make a very reliable database, either structured or unstructured. The second thing we're going to talk about is the data analyst. The data analyst is involved in the aggregation and labeling of this data. They are involved in the interpretation of the data, the querying of the data, and generating information from the stored data. They also work with or are also referred to as business analysts or product managers. An example is if a data analyst is working for, let's say, a supermarket. They can take the data that is stored in their POS system, and they can look at the products, group them, query the data to find which products are usually sold together, so that they can make offers, combine products, make offers which can be helpful for the specific organization. They can also look at trend lines to see which products are failing. They can also look at things like their time series analysis to see whether the product is failing or the product is doing well, etc., etc. They usually just provide information, impactful information, insight that can help a business grow. This part is very important and is the biggest part in anything data related. Most of the people that work as data analysts usually do the collection part. They usually move the data and they explore the data. Remember, for a data engineer, the data has to be massive, because in order for you to require a data pipeline, you have to have massive data. But for a data analyst, they can work with enormous data or can work with small data, as long as they provide impact and insight in the specific field. Let's move on to the data scientist. The data scientist covers the other parts where there's the learning, the optimization, and the artificial intelligence, etc. In the learning and optimization, there's things like A/B testing, where, for example, you can have two versions of the same website. Version A sent to half of the clients, version B sent to the half of the clients, and then monitoring and seeing if more people like A or more people like B, how many sites visits you get from A, how many sites visits you get from B, how much watch time people look at the website in A and B to see which one is better. Or another example, changing the color of a like button in your social network or social website from yellow to maybe green, and then giving half of the people a yellow like button, half of the other people a blue like button, and then seeing how much more times people like when it's yellow and when it's blue, so that you can understand how to actually manipulate this data. This is called A/B testing. Then there's the creation of simple machine learning algorithms, which usually involve either regression or classification, and you can use simple machine learning pre-created algorithms, or you can also use these pre-created algorithms together with things like rolling averages to try and increase the accuracy and precision of these machine learning algorithms. This is where data science comes in, and it is usually involved in this. The other part of also data scientists is artificial intelligence and deep learning. Deep learning is usually is the using of neural network type of nodes to try and help a machine learn a couple of things. I'll have another video explaining machine learning and artificial intelligence and deep learning, the differences, so we'll not go too much deep into that, just have to look at that other video. But this is how the hierarchy of needs for data science works. So the first one is collection, movement of the data, which is usually done by the data engineer by creation of pipelines. There's then the exploration of the data by cleaning, detecting anomalies, and this is usually done by either the data engineer or the data analyst, but the data analyst is more involved in the aggregation and the labeling of the data, where they create impact by just querying the data, interpreting the data to find impactful information that can help an organization. Then the learning and the optimization part is where the data scientist comes in, where there's A/B testing, creation of simple machine learning algorithms, up to the creation of deep learning algorithms using neural networks and artificial intelligence. I hope this video is informative. Throw a like, subscribe, because it helps with the algorithm, the YouTube algorithm. Thank you very much for watching. See you in the next one.